Is this thing on? Does this work? Okay. Hey everybody. Happy Tuesday, people that are coming out to a nerd evening on a Tuesday. We salute you. Thank you. Anybody? Whoa, that's bright. Anybody that's like way in the back, if you are comfortable moving forward, it's going to be a lot easier to kind of be part of the presentation, listen to the talk and everything. We're just editing slides. We're doing it live. Yeah. I'm kind of blown away by how nice the spread is here at Sentry. Like, thank you. Like, I have no complaints about eating pizza, but like, I'll definitely take some steak. Yeah, thank you, Sentry, for hosting us. I think we'll also have a, well, not only a speaker from Sentry later, but woo! But we'll also have oh, no, I'm skipping ahead. Okay. I think I mentioned we were just putting together these slides. So tonight we'll have Aiden Bai from React Scan. If you're scared about the performance of your React app, you should not share your React app with Aiden. But he'll be talking to us about performance. And then Cody from Sentry talk about dev experience and the amazing things with Sentry. Let's see what else we got here. I totally prepared. I know what these slides are. We will have our next month meetup at Convex. Yeah, I don't know if we have, do we have speakers for that, Andre?
Yeah, I will be speaking. I will be practicing my conference talk at Convex. So if you're interested in image optimization, which is kind of performance related also, I guess, then definitely join us. It is already up on our Luma calendar. So if you haven't subscribed yet, be prepared for some spam because we do send out a lot of notifications. I don't know why Luma is doing that they send an SMS, a push notification, and an email. I don't know. It's not us.
I think it's because you click confirm. Yes, send to all those.
No, that is, they should know.
Yeah. Sorry. Can I say an embarrassing thing? Okay, it'll be embarrassing for you though. Is that okay?
Go ahead.
So Andre has been working on this image optimization library, and he's been working on it in public, open source. And I just come across a live stream. Is this working? It's kind of a live stream from a dude in Utah who was, I think, for like 4 hours streaming about like setting up his Epic stack so that it could work and bring in the image optimization library that you've been working on in open source. I think that's pretty awesome. So just round of applause for Andre and open source.
When you said it's going to be embarrassing, I was expecting something else, but that's cool.
Usually when someone's like, is it okay if I do something embarrassing? It's going to be about them, but yeah. Yeah, so please hop on our Discord. It's a great community. Other people here, it's a way for us to stay in touch in between in-person events. It's a great place to learn about web development, or some people do mobile development too.
Minority. We don't talk about these people.
It's also a great place to share your wisdom, share your knowledge with the community. So please hop on that Discord.
Yeah. We're also trying out new event formats. Maybe one in March. So if you're interested to learn more, we have limited seats. Join the Discord because I'm definitely going to publish it there. But yeah.
Cool. All right, we're going to stop with our little thing and hand it over to the smart people. Aiden, do you want to kick us off?
How's it going, guys? My name is Aiden. I work at Million. Today I'll be giving a presentation on React renders and if they matter or not. So no, because we all use M3 MacBooks anyway, so it doesn't matter. The end. Okay. So it's a little bit more complicated than that. So I'll give you a bit of context on me. I'm Aiden. I created React Scan. I run a company called Million. Million is a company that builds tools to help optimize web performance, and React Scan is a tool to design to help you find performance optimizations in your app. So you might have seen some of our posts on Twitter. Like a couple months ago, is there any way I can raise this mic? Okay, great. Yeah, perfect. So I made a series of tweets. You might have seen like GitHub, TikTok, Facebook, whatever. And I was like, hey, like, why is your entire app re-rendering like 3,000 times? So we can, oops, don't look at that. So this is Twitter, sorry, GitHub. And you can see like every time I scroll, every single line on the GitHub thing is re-rendering. And so what's kind of cool was like, I was like, hey, like, here's how you solve it, and then blah, 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 blah. And I don't, this like dev role from GitHub, shout out Martin, fixed it in a day. And he's like, hey, like, oh, we like pushed a fix. And then they actually fixed it. So, that's kind of cool. Like, that's like kind of some real world impact from React Scan. Let's see what's going on. So yeah, like basically React Scan help companies to optimize websites. But like, what exactly is a render? Like you've probably seen this concept of React renders online, and it's like, great, like what does that exactly mean? Is it like the page is refreshing or like the DOM is mutating? God damn it. It's not rendering, come on. At least one render, man. Come on. Okay, anyways, I'll just freeball. Okay, cool. Like renders are basically a function call. So like imagine in your head you have this like React app component, and like it like uses some hooks, maybe some state, and returns some JSX. A render is basically just a function call. Imagine you just call that app with some like props as parameters. That's what a render is. So there's a lot of discussion on like whether React renders are actually bad or good on Twitter. And it's like, they're both true. Like they're both bad and good, but not for the reasons you think. Fundamentally, renders are just a function call. And just like any function, the problem with the performance is usually the side effects. So think like some hooks that run, or if you like send a massive analytics thing in a use effect, or you return a lot of JSX and change a lot of stuff on the DOM. So side effects are the cause of the bad performance, and renders are usually somewhere in the middle, right? You can't cause bad performance if you don't render something. See if it works. Great. Okay, it doesn't. So when you debug a React app, you have to be pretty mindful of this. React Scan is a tool that helps you find these things. So I'll give you a quick demo. Every time you see one of these flashes on your screen, it's basically a render. So imagine like you can see like this note editor function running here. This is a render. It's literally, React is literally calling the function here. But if you notice when I like try typing, like it's super slow. You can see at the top right, the FPS drops to 2 and just comes back up. And so while like there's a bunch of flashes on the screen, not every flash is of importance. Today we shipped a thing called notifications for React Scan. So basically you can click this like bell icon, and it tells you exactly what is slow in your app. So here you can see like, oh, like I just typed in note editor, right? Like I can click on note editor, see what exactly is causing it, see what components cause it, and then figure out from there. So that's the gist of React Scan. The second part is like, okay, like I found some performance problems inside of my app. Like, what do I do? And like some people are like, yeah, just like, bro, just React memo everything in your app. And that's one way, and you can surely do that, but you might notice that it probably doesn't do much. The second option is like, fuck it, who cares about React renders anyway? Let's just like render the entire thing because I don't care and I'm not paid enough to do it. So we have a feature in React Scan called prompts. And so who here uses like Cursor or some Copilot, or you should probably be using Cursor. Yeah, so this will allow you to, you can just copy the prompts, paste it into Cursor, and then it will try to fix the problem for you. I'm not going to demo it because it might fail. So that's pretty cool. Like, I like cool. Like Aiden, like this is an interesting thing. I see a bunch of data on there. Like, why should I use React Scan? Who here is trying to debug a performance problem? Okay, no, a good bit. Who here has used like React Profiler or Chrome Profiler? Who here has enjoyed it? Congratulations. I'm gonna hire you now. So like, profilers are really hard to use. Like we can, let's just do it right now live. So profilers are basically a tool where you can record parts of your app, and then it will give you like a call stack of functions that ran. So here, we can see a bunch of information, right? There's like a super dense amount of information. The biggest thing is like you can take a look at like these long tasks and like go down the line and figure out what actually is the problem. But you probably noticed something, right? Like this is like, I'm gonna have to spend at least an hour in this thing to figure out what's going on. Like this is like, you gotta be like a professor, academic, PhD graduate in like performance to figure this out. And like this is pervasive in all performance tools today. If you use React Profiler, if you use Sentry, so no, sorry Sentry. If you use Datadog or New Relic, they all have traces, profiles, and like it's just like super complicated. Like why I have like a thing, like even I'm not smart enough to do this, and I've been doing this for the past 4 years. So I don't know what else to say, but you should try out React Scan. It makes a lot of things simpler. I had some other stuff at the presentation, but I think the product speaks for itself. So yeah, any questions? Right. Please.
Hello.
So optimizing React Native. Sorry, go ahead.
Right. So I think during your presentation, you did mention React Memo, and it felt a little bit dismissive. Maybe I'm wrong, but I'm wondering like what other like very common sources of like multiple renderings that can be avoided are there?
Okay, so different types of React rendering. Is that the question? Like
Other than applying React Memo, what are some common fixes that you have used to reduce this rendering time?
yeah, so rendering can come from many different sources. Your app may render a lot. Like if you're building a stocks visualization dashboard, that thing has got to render like so many times a second. If you're building like a personal site, it probably shouldn't render at all. So inherently, like rendering is not a bad thing. The question is, when does rendering actually matter in your app? So like if you're building a stocks visualization dashboard, like and the entire app is re-rendering, even if it doesn't change, that's a problem. Performance, like stock visualization software needs to be extremely performant because reasons, right? Like you need the interface needs to be very fast. And like tools like React Scan or React Compiler can try to help figure out where the bottlenecks are and help you fix it. Did that answer the question? So maybe I didn't understand it. Yeah.
I'm just saying, like, let's say you find like great, you find like a bunch of places where rendering is too long. So, and you say, okay, React Memo is one solution, but I'm wondering, like, since you do this day and night, it seems, like, what other kind of errors and solutions that you commonly find? Like, what is something that you say, like, these are the top 3 things that we are doing wrong, such as rendering is taking too long?
Yeah. Yeah. First, profile, measure, figure out what's broken. Then use React compiler, see if it works. If it doesn't work, look at your state management. That's usually the source of it. And then look at your data fetching.
Yeah, so with the new React 19 version, there's no need to, wrap components with memo or use callback hooks, use callback and stuff like that, because the compiler itself has now inbuilt capabilities. So do you think like just migrating to React 19 would at least diminish most of the rendering issues?
Depends on your app. You should try it. If it works, it works.
Like,
I've
just want to
seen-
know what other sources are really contributing heavily on re-rendering apart from just, wrapping component with memo and use callbacks.
I mean, like, first you should try, like, does React compiler solve my app? For a good amount of apps, it will solve it. But if you've actually ran like a decently complicated React app, it might not impact that much. Like, at least from my personal experience, I don't know from other people's experiences. I would just say try, and then you just got to measure and then figure out what's bad. Like, the basic process to solving any performance issue is figure out what's the thing that's causing the most time or lag or whatever, and then just optimize that down. Yeah. I don't think that really answers the question, but that's kind of the answer. Yeah. It does, but like, when is rendering really the bottleneck? Like at the end of the day, it's like, hey, like rendering, the rendering itself is just a function call. The side effects are usually the bad part. So React compiler may solve some of like DOM mutations, so you don't have to do as much like reconciliation, like diffing as you need. But like, let's say some useEffects runs, and then it runs a very long, expensive computational process. That's not memoized, right? That's still gonna run and slow down your app.
All right, so you've mentioned side effects and data loading and stuff like that. I'm guessing maybe you have some analytics on how people use React Scan and what they find. What has been like the most surprising thing you've seen that causes slow renders?
Oh man, usually it comes down to, okay, like it's shit code, but it's not because the engineers want to write shit code. It's because, like any app, it starts very small and you build it up. But the problem is like you start with like a decently okay architecture, and then like your manager's like, hey, like or like ICP changed or requirements changed. Now we have to add this thing. Then your architecture isn't optimal for whatever application, and then you just get a shitload of like slop added to your code base, and everything is just extremely unoptimized. And so, like as a performance engineer, it's my job to figure out what parts of your slop can be optimized to make the user experience better. That's basically the reason. Yeah.
Nice. So can you use React Scan to like make it easier for product engineers to not create that slop?
It helps you figure out where the slop is. So the two types of side effects we track today are interactions and FPS drops. So if your page, like you're scrolling and then your page freezes, that's an FPS drop. If you click on something and the reaction is super slow, that's an interactivity thing.
So could I use React Scan as like a performance budget in a GitHub action that blocks merging if those metrics drop too low?
Shopify uses us for that, but that's not a common use case. The most common use case is figuring out which parts of the app are slow.
Thanks. That sounds awesome.
Could you maybe elaborate on like how they integrate that in like their CI?
We have like a programmatic API that tells you what components / what interactions, like basically the timings of them. And so some people do this incorrectly where they say like the component must run less than 7 times. That's not how you do it. It's usually like, hey, like if the average interaction time is over some amount of time, then it's like probably bad. Or like you can track the regressions over a historical period. So like maybe use Sentry for this. Like INP went from 500 to 1,000. That's probably a regression.
Per time in production, or is it like you're running an end-to-end test and also React Scan is there?
I think best you figure out with production because it's real user data, but sometimes the feedback loop is very long and the data is noisy. So you can try ET test maybe a first step option.
Questions? Yeah. Come back. You and then you.
Can you use React Scan notifications in non-development environments?
It's just a script tag. So you just drop it in and then you can use it wherever. Like I ran it on production on Twitter. You can run it on localhost if you want.
Will I be able to see like the stack trace, component tree, etc.?
We don't support stack traces and component tree. Like we had it originally, but people don't really care apparently. So it's like, I was like, oh, we just ended up with this UI. Yeah.
Nice, thank you.
Hello. I'm curious about how do you get the nice namings like note button and you know like if you use like for example arrow functions for your components, do you have to like label them to make it look
Using display
nice for
names,
the
yeah.
demo? Okay, so that's a requirement. How does it look otherwise?
Sorry?
If I use your product with an app that doesn't set the names for components.
In production, we recommend using a display name adder. So like it'll basically transform your code, add display names to each function, and you can see it.
Okay, thanks.
Any other questions? I have one.
Thank you so much, guys.
Could you maybe walk us through like just like the full flow of like, okay, you found
Yep.
something that's like unperforming, like, and then manually kind of how do you find the root cause and fix it?
Yeah, let's do that. I should have done that in the first place.
It's great.
Okay, so we have this app. You guys know it's slow. When I add stuff, let me turn off this first. Take a look at the FPS in the top right. Do you guys see that? That's what you should take a look at. When I like add notes here, you can see that the FPS is dropping, right? Or like I type. And so this is a really slow app, especially when the notes gets really high. Cool. How do I solve this with React Scan? First, you can turn it on and see like what's the general heuristics of why this is occurring. So most basic thing is like everything is re-rendering on the screen. Not necessarily bad, but that's pretty suspicious. Next, I can click on this bell icon and see what's the biggest causes. So I see when I clicked on this note button here, there's like a breakdown of what happened. And so like some JavaScript or React hooks caused some stuff here. And then the second thing is the note button component itself is re-rendering a bunch and taking up a bunch of time. So if you take a look, it's 115 milliseconds for the JavaScript and React hooks and 61 milliseconds for the actual note button. Cool. Now I know how to figure this out. So first we can use cursor, or we could just debug it manually. So let's go here. Cool. Like I see this note button component. I go here, and I know this is probably the source or cause of the component. So the first thing I should do is probably memoize it, right? Yeah, that's cool. Memoized it. Why is this happening? Yeah, fuck that. I don't care. Okay. Awesome. Now that we memorize it, let's take a look what happens. Uh-oh, why is the entire thing still rendering? That's probably bad. And so let's take a closer look. When I click on this note button, I can see the prop that exactly changed here. So here it's onNote activated that's triggering the note button to run, even though it's memoized. So now we have to stabilize the onNote activated prop. So let me zoom in for you guys. Cool. Let's go back here. This is the problem. let's see where it's being used. So I'm going to reference search for no button. It's nowhere, okay. But good luck, good thing I know where it is. And I see that there's this function here. So this is a huge red flag to me because whenever this renders, this like function is being recreated for every render, which means it's causing the memoization to like bust. It's like not caching basically. So what I can do is I can just pass the onNode activated function down and pass the ID which we depend on. Use it here. And then try again. So let's see if I click here. Now it's like pretty dang fast. And we can validate it too, right? All these no buttons are now green. So problem 1 solved. Any questions? Amazing.
Great. Thank you so much.
Thank you so much.
All right. Thank you, Aiden. I have a confession. I haven't used React Scan, and after seeing that, I need to definitely go use React Scan. So it's really cool. So next up, we got Cody, who likes developer experience. Is that correct? Do you? Okay. Okay. Awesome.
A little bit. Hello, everyone. So we're going to talk a little bit today about anti-crash course and building better errors and traces. So obviously I work for Sentry. These are topics near and dear to my heart. My name is Cody. I work here at Sentry. I look after developer experience. Yes, this is the same shirt that was in that picture. Everyone was wondering, I know. I look after both our docs team, our product, a little bit of product functionality, not in the sense of running product teams. I do a little bit of product work, and I look after our developer relations and developer experience teams. You can talk to me after this about anything from building software, AI. I'm a big fan of building an AI, barbecue. If you want to talk about barbecue, love that. Any order is good with me, and you can find me on Twitter at Cody D. Arkland. So as we cruise through this topic, I think we spend a lot of effort to try and make our code work. And today we're going to talk more about how we make it fail and how we make it fail in a useful way. I don't expect everyone to like zoom in and look at all of these, but it's more to think about like as we build these applications, we follow this kind of path through how we manage errors and problems that come up inside of apps. A lot of times I'm initially just concerned with like, does it work? Can I get things back? When it starts to break, I start layering in things to catch errors better. I make it more complicated by creating custom error objects. I start bringing in things like error boundaries. And all of these things are really meant to bring additional context back to the users who are trying to use my application or back to the people who are trying to fix problems inside of it. And we spend a lot of engineering effort to get there. And the thing about context is context gets pretty complicated. I'm blasting through these slides because we're going to spend most of our time in an application, but something I appreciate a lot about good like error code, a good error catching code is things that bring additional context. So who was impacted by the issue? What error were they actually having? What was the performance at the time? What component was having a problem? What API? What was the return? But the thing is, as we continue to build things like that, it gets a lot more complex inside of our code base and it starts to become something that has to be maintained throughout the rest of our application. It becomes different from other apps in our environment. And so again, these are all things that get complicated as we start building more complex applications. Things that I care about inside of context. Who is impacted from where? Beyond their local host, when this is actually hosted out inside of a public environment, how is it being actually used? How are these errors and problems being aggregated inside of a system that we can actually see? What's the impact of it on both the application itself, thinking about like Aiden's performance examples, but also like downstream services and connected systems. How is that being impacted? And the thing is, this changes a lot also inside of the AI space. When we think of things like a web application, we can go on and we can watch a crash happen. We can pop into console and watch errors that pop up inside of there. Sometimes in really bad cases, the application itself crashes right in front of you. But I was talking to a few people during the meetup part of this. A lot of times when you're working inside of some of the LLM tools, especially like I have Claude up here or I have Anthropic here, a lot of times the errors end up getting masked behind the conversational context. So it's trying to let you know, I'm trying this a different way. I'm trying to figure out a different way to do this. In this example, both of those areas right there that it's retrying are actual errors that are happening behind the scenes. But what's happening here, and this is an MCP tool call, we're going to do a little demo showing that in a little bit. But what's happening there are errors that I would never know about otherwise. These are failed API calls, this problem side of the code, but MCP in this case and most agent workflows don't really have great ways to get what's happening inside of them out. They kind of function a little bit like a black box, and it's a space that as it's getting more popular and being used a lot more or starting to grow a lot more, people are just now starting to look inside of them and say, hey, how can I start pulling out actual useful information from it? And so again, natural language often hides the problems that are happening and some of like the issues, but also performance in this case isn't front and center. We have the loading screen, we have the I'm thinking, all of these things are stuff that the LM is doing automatically. And so a lot of times we might be missing poorly implemented code, right? As Aiden would say, shit code that ultimately is causing it to perform worse or take longer to actually process. And so a lot of this stuff doesn't end up being immediately visible, but it's all context that I want to be able to have in the actual performance of the application. And so let's jump into a couple of examples and talk through it. Then I want to show how we start to bring a little bit more context into those and make it more useful. And then we'll start looking at a little bit of tracing also. So I slammed this application together. Again, everyone's favorite tool, Cursor, helped me build this. And so we're going to move through a couple of different examples. When we look at things like the simple try-catch approach, we all probably use this every single day. Oh, the Zoom doesn't work so well on this. That's not awesome. So sorry for the people in the way back. Simple try-catch runs. If there's a problem, or if it goes through successfully, all is good. If there's a problem, something like all zeros, that worked. We go blank. There we go. We get an error back, right? And there's not a lot of context given here beyond just the problem that happened. So we get a good indicator of what went wrong. But again, we don't necessarily have context on who was impacted, what the performance impacts of that were, additional information about the environment. It's just telling us, hey, this isn't a good property. So then we, as all good engineers do, overcomplicate a problem by creating things like custom error objects and handlers that we can feed in information into that hopefully give us more context back. And so in this case, if I go in and I drop in a 500, I can see I'm getting a much more detailed error message now in here and a lot more information back. But now this is something that I've constructed and had to move throughout my code base, and I'm using elsewhere as well. And I still have to handle aggregation of this information. So there's a lot of things that I'm not getting out of this despite getting more information back to the user. And ultimately, this is only showing up when something goes wrong and pops up right in front of them, front and center. And then beyond that, we have things like error boundaries that work more from like a UI component level and being able to handle a catch when something goes wrong inside of the application. What's great about this is being able to carry that over and actually perform additional actions when an error happens and maybe collect additional information there. But again, this another thing that performs a little bit different from the rest of the application, the rest of the model of how we're actually capturing errors, traces, and problems. And so what I like about Sentry is like I can take all of these things that are happening normally inside of my environment, and I can actually build a bunch more context off of actual problems that are happening. I can start to bring in a lot more information into those errors. So for example, when I go in and do the initial instrumentation, I'll go and run these real quick. Once these are up and running, I can come into my application itself. I'm inside of Sentry now. All of those things that I was actually doing were triggering issues to be created inside of Sentry that now has a ton more information. So we can see if I go up and refresh the screen real fast because we were a little out of date. There, we can see things like this type error here. When I come inside, I'm getting a ton more context about what's actually going wrong inside of here. I can even watch a replay of what the user saw inside of that experience as they were going through and having that error happen. I can see breadcrumbs of how they were interacting throughout the application. So as they were going through and navigating inside of the app, the things they were actually seeing. And I even go a level further and I start getting traces back for the interactions that happened behind the things they actually did. So as we look at API calls that are being made, interactions and different loading throughout the system, all of these are being captured as well. And so again, in this case, with pretty minimal instrumentation, I'm able to get a ton more context out of the problems that are happening inside of the application. And like I said, all of those were being tracked inside of that issues view. So all of these, as I was going through and using the application and doing those different interactions, all of these issues were being created automatically for me that I can go in and start to research and pull more information out of. We can even take a lot of this context and feed it into, we have an agent that runs inside of here called AutoFix. We can take all of that information and that context, run it through, and have it actually try to come up with a solution using AI. But again, context is great. We love that. But what's that? We're skipping ahead in the Q&A session now. So we have session replay, and session replay is gathering up all of like the steps of interaction in that, and then it stitches them back together on the front end. So it pulls all the individual interactions and then reassembles them inside of Sentry. So the cool thing about once you jump in and you have Sentry instrumented, you get the error tracking automatically, and that stuff gives you all of the context, and you can start to attach additional information into your app, or I'm sorry, into your actual session. But you also get traces and spans as part of that also. And what's great about those is you can start to add in additional context into the actual calls to backend systems. So when you look at the interactions from a front end, as you click on an API that goes then out and calls a return from a database somewhere, we can actually instrument all of the calls and see how long did that database query actually take to accomplish? How long did the rendering take on the front end to complete? How long did the page load take? So we go in, we can start to pull something like pulling these products. We can trigger an error here. All of these are triggering traces to be created for the interactions, and then spans inside of that trace for each individual action. So now when I go back into here and I jump into our project again, all of these traces are showing up on the bottom. It takes a couple seconds to load. But I could go in and look at things like the navigation traces and show interactions throughout navigation on the app. On the right-hand side, I can dive in and start seeing additional details around that span. So duration, I can see specific metrics. So for example, in most of my AI calls inside of applications I write, I include things like the prompt that I'm calling. I include the response. I include the total token usage. So all these things that I would normally want to use to debug a problem inside of like an interaction, I'm adding to those traces and spans that I can pull out later. I can also use that querying engine in here to actually build out queries and aggregate that data out however I want to see it. So if I want to build dashboard views or I want to create alerts off of changes in these all these performances, I can do that as well. And so over here on the left, you can see this is what it looks like when we create an actual span inside of Sentry. So we can give the data we want to capture, where it starts, the functions that we want to run inside of that span that we want to be tracked, any sub functions that we want to do and sub spans that we want to run inside of there can be also captured. And then metrics that get ultimately fed back into Sentry to use for part of that querying aggregation show up here as well. And going back to where I started in this, the big thing is like we want to be able to enrich these errors that are coming through. We want to be able to build better errors and build better spans and traces that have more information. And so there's a ton of tools inside of Sentry that let you bring additional things in. So for example, if I want to know who's actually impacted by an error that's going on or trace that's going on, I can come in and I can set the user object to it and set part of the identity that's associated with it so that now when I go into Sentry, I can start to see who actually was the one that had this error. I can see unique users that are impacted by it. I can see how often individual users are having that same problem. I can start to tag these based on different properties. So for example, if I wanted to tag off of screen configurations, if I wanted to set tag off of specific components, I could do that as well. OS is an example. If I wanted to manually add breadcrumbs, so we automatically instrument breadcrumbs as you click throughout the application, but what if I wanted to add specific ones on for the start of individual interactions or when something happened inside of the application? I can add breadcrumbs for that that'll show up in the replay view as well and within the actual issue view. And then again, being able to custom instrument spans and add additional data in there as I want to without having a bunch of friction around figuring out where do I add these calls to return back in the application. I can do that all natively from the traces and spans interface. So now when I come back in here, if I refresh this again, we should have some new ones that show some of those recent queries. So for example, if I go into this query, I can see information about what it actually returned back. I can see the tree of interactions between the different calls and how those are actually represented inside of the app itself. And again, you'll see as I'm moving through, the time is updating throughout every time I go in and do these different interactions. So we're capturing these live throughout the entire application session. So that's cool, but this is also just a kind of a toy demo app that's really designed just to show interactions inside of Sentry and dump information in. But there are definitely some real world use cases that are a lot more realistic, a lot more tangible. I spent the weekend working with my boss. We went in and started hacking around on MCP. Who's used MCP in the room before? Okay, so good. Rahul raised his hand. That's my boss back there. He used it. So MCP is Model Context Protocol. Anthropic started it, and it's something that's getting a lot of traction. And what it does is it's the structure that's set up around how AI agents both interact, as well as tool calls interact, and being able to create some standard models around that. There's a lot of really cool tools that can be used inside of MCP that you can attach right into Cursor. So for example, my favorite one that I was showing earlier was I built one that uses Firecrawl. Who's used Firecrawl before? I love it. We got one out there. So Firecrawl will go out and scrape a website, turn all of the information on that website into Markdown, and then you can feed it back into an LLM and get information out of it. All of these tool calls happen as just regular functions inside of an app. So if I go into Cursor and we jump into this MCP Firecrawl, I'm not going to go all the way into all of this, but ultimately these are just tool calls that are scraping off of a website. There's not a lot of complexity in here. It's making a call with an SDK, giving it a URL, and pulling data out. So there's not a lot of hard things in here, but this is really just a function. And so as these MCP tools run, they run effectively like an agent runs. And as I mentioned earlier in the presentation, what's hard about agent runs is they run inside of a black box. So if there's a problem inside of that tool call, which we had working on the Sentry MCP over the weekend, as we were trying to instrument new paths, instrument new calls out, we weren't able to tell when errors were actually happening. Sometimes it would say, oh, I need to try a different structure for the URL. But what we actually found out behind the scenes is it was throwing an error. It was a poorly constructed function, bad code that was written, but we didn't have any way of telling that without. And so what I started thinking about was ultimately what we wrote inside of there was a Python script. The Firecrawl one I wrote is in Node. We have SDKs for both of these. I can run Sentry inside of MCP and have all of the same things that we talked about just now running alongside the tool call. So if I want to be able to see errors that are coming up with specific runs, I can get those now. If I want to be able to see tracing and span performance for individual tool chain calls, I can do that as well. And so I'll give a quick demo of what it looks like when we run something like an MCP or a Firecrawl call. Maybe. We don't get to do that. Yeah, that's great. So you'll see up top, I said, use Firecrawl to get the Sentry installation instructions for Ruby. I just grabbed a random language. It's going out now to the URL, so it understands how to go search for what the URL is for that. It's grabbing that, and it's starting to actually parse that information out. And what it's going to do, oh, it actually got it on the first try. It'll jump between multiple URLs and start to parse that out. Every time it does that, that's another trace that's being, or another span that's being captured. What's happened here is it goes through and pulls out all of those instructions without all of the extra documentation and just spells out what to do to actually install Sentry on Ruby in this case. But now when I go back into Sentry, maybe. If I go into the traces for new crawl, which is the project associated with that, we can see this scrape website call that was grabbed right away. So that took 12 seconds for it to run through that call. And I can see all of the details associated with that actual call down here. If there was an error in this, like for example, we were trying to instrument capturing traces via the Sentry MCP and we couldn't get it to work over the weekend, you would see those errors represented in here also. So if I go back into the issues view, we can see an example in here of, oops, wrong project. Here we go. This is one where it wasn't able to actually effectively parse out the information. So in this case, it's looking for a URL or org slug issue, whatever it was reading, it wasn't actually able to parse that out successfully, and it throws an error. MCP won't actually tell me this. MCP will say, I'm trying a different path. I'm going to try to gather this information in a different way. I'm going to try to pull this out in a different, through a different tool call. And it'll continually run these, burn a ton of your Anthropic credits along the way. But now I get this nice view into what it is actually, like what monitoring looks like within the agent that's running here. This MCP server can easily be ran inside a cursor. So I could have MCP servers for Firecrawl running. I could have an MCP server running for Sentry that's checking issues. So when a problem happens in my code, the MCP server will go out, check Sentry for the issue, pull the issue details back, and then feed that back into Cursor to help fix it, right? All of those things, if I've instrumented this in the right way, are going to have traces and spans associated with them. I'm going to be able to debug the performance of building that and build much better agents along the way. So I think things like this are going to become a lot more popular as people start building agents and as agents become less of like a company crafting it and more developers like all of us going in and building out something to actually use. These are going to be tools that we're going to want to use to be able to understand how those things are performing under the hood, because there's a lot of things that LLMs are doing that we don't always get exposed to from an inference standpoint, from RAG standpoint. And tools like this will give you a lot clearer view into it. You don't get things like replay, but ultimately you get all of the context of the conversation back and forth, all of the errors that are happening, and ultimately the performance that is associated with it also. So I'll be around for a bit if anybody wants to talk all things MCP or you want to dive into Sentry and learn more about it. But that was what I got for you all tonight. Any questions?
Yeah, for the like tracing and error handling, have you played around at all with effect yet? And if you have, what's your kind of impression of it?
I missed that. Have I played with what?
With effect, yes. The like effect library.
I have not.
Oh, okay.
I've not.
I'll sync up with you after.
Yeah, let's talk after. I'm interested.
Effect website. Effect, yes. No? Yeah. Oh, yeah. The explanation of what it is, it's typed error handling, and it comes with like telemetry.
Oh, nice.
So it does like the tracing kind of like built in, and then goes out to, I think you can do whatever tracing providers, but has OTel built in.
Interesting. Very cool. Any other questions?
I was just asking for a friend, by the way. I'm just kidding.
I see no hands. Oh, I see one.
Yeah, here. Okay. Love Sentry. I've been using it in production for many years, and it's awesome. I've been more and more annoyed by ad blockers who they will block amplitude mixed panel and also Sentry. And so we've been moving more and more stuff to sort of server code handling, and like front end is more and more fuzzy. And I was wondering, like, how are you guys thinking about this? Is there like, are you trying to hack around those ad blockers or just accept them and move on?
It's a little bit of whack-a-mole, because like as you find new solutions for it, they come up with new ways. One of the common ways, like depending upon what stack you're using, like we have a handler for like Next.js that'll let you route it through like a monitoring endpoint that gets around that. But the downside of that is, like, if you're on a hosting provider, you're going to incur more cost as far as like information feeding through that route now. So it's a little bit of whack-a-mole and trying to figure out like the best ways around that. But it's a common concern. I think like in some of those frameworks, like the monitoring endpoints that let you tunnel that information through is a really good approach. But you can, if you want to grab my contact info, I can always like take a look at your setup and try to help you figure out an answer also.
So proxy or Sentry on-prem?
That's Sentry, Sentry on-prem
a
too.
thing? Is
That's
that a thing?
There is OSS Sentry.
Okay.
Yeah, I still want to hear more about these this video that it generates, because that's kind of mystifying. Like, does it send all the user state in order to create that? Like, how does it know exactly what it looks like for the user?
So it's capturing that during as the interaction happens, especially for when you have, because you set up when you turn on inside the SDK, you instrument out like replays to be turned on, and you set a sample for how often replays are being captured. So like in most of my setups, I capture replays for 100% of error sessions, and then I leave it at like 10 to 20% sample rate for regular sessions. But as the user interacts throughout the application, like it's gathering up like effectively like the frames of interaction, then saving those back as data on the back end, and then it reassembles them in the replay UI.
Wait, so what do these frames look like?
I don't have it handy to show, but I can show you an example from like the source code later if you grab me.
I'm just really mystified by this, because it sounds like you're going to have to send all of the users' data in order to recreate that.
No, so just what's being captured on screen. Now, in my case, there's a good thing to call out here. By default, let's see if I can get back into, there we go. By default, we keep masking turned on. So as an example, what masking would do. So you see all the text on the screen right now because I have masking disabled, but by default it's on. So you would normally see these all as asterisks. All of those values would be blocked out. You wouldn't be able, all you'd see is the overall like structure of the UI. You wouldn't see the individual like content.
I see asterisks in that right now. Username, subscription.
Oh, that's just because I think that's the app itself had it. I have the PII data one still masked, but not general text. But if you had a general text, it would mask all of it.
Okay, interesting.
I could just say, well, Sentry user, love it. Web, mobile, the session replay is like game changer. It's like magic.
Yeah, session replay is amazing.
Yeah, you're like, because the bread traces. It's very late. The breadcrumbs are like useful. It's like the go-to, right? But then now session replay, you don't have to like imagine what the user is like kind of going through by like stepping through the breadcrumbs. You can just watch.
And what's cool is when you play it, it'll actually navigate through the breadcrumb on the right as it moves through, so you can watch the actual full session take place all the way through. And then on the bottom timeline view, you can see some of the specific call outs of interactions that are happening inside and all that. See someone?
How do you guys manage the performance overhead of streaming all this data? Because it looks like you have a lot of capabilities and features. Like, do you guys?
I'm having a hard time hearing you.
How do you guys manage performance overhead of using Sentry? Like, is it a very heavy package? Like, it looks like you have a lot of features and capabilities. So
it's pretty lightweight overall. We pay pretty close attention to performance, and like it's something that we get asked about a lot. So it's something that like we're constantly watching for optimizations around. Again, similar to whack-a-mole answer, like as things grow and as you add additional capabilities, you find areas that you need to optimize around. It's not something that comes up that often, like as far as, because we tend to stay pretty far ahead of it, but it is something we're constantly watching in front of. I don't have, unfortunately, there's not an easy answer to that in the sense of like, we do steps 5 through 7 all the time. But it is something that we pay really close attention to.
do you have any examples of like performance issues in the past that you guys kind of
not off the
solved?
top of my head. I bet I can get some though if you come find me afterwards.
Okay, thanks.
I'm gonna come to you in just a second up there.
You can shout it. I can. So the question is, what's the relationship between open telemetry and what we're doing inside of Sentry? It's something we use a lot, and we're like doing more and more to bring more open, like to allow more open telemetry information to come in. And so we use open telemetry for certain parts of the application, so they can coexist between each other without any sort of an issue. But we are adding more like abilities inside the platform to like use more open telemetry and to pull more of that in. So if you're like a heavy hotel shop, being able to pull more of that information in. Any other questions? I'll repeat it for you.
Something breaks, you go to Sentry, you check. But you don't know that that's going to break, right? You need to add plans later when it breaks and then check again. So like
So the question was around what are the areas that you can add custom spans to, and areas where you might use those spans, and is it always, I'm going to dig into your question more here, is it always responsive in the sense of a problem happens, so you go create a span? I actually find that the majority of the conversations I end up having are people who are instrumenting that tracing for like to be a little bit more predictive in the sense, not predictive, but to get ahead of a problem. So they instrument it to understand, hey, I have a call here that's going to happen. I want to see what the performance is. We're already going to capture the error anyways. I'll get back to the beginning of your question, where can you put a span in a second, but like we're already instrumenting the error catch anyways. So we're less concerned with like the error happening inside of the span because that's already being captured. We do capture it and it shows up in like in the view, and you probably saw it in the demo. But we're more concerned with the metrics that matter inside of that object. So like we talked about Shopify earlier, there's a few people who use Shopify inside of like Sentry and do attaching things like cart totals and the amount of products and failed transactions, how many things were in the cart when it failed, so that you can start to do aggregations off of that and you can start to do queries off of it. You can create spans all over the place, and we do a lot to make sure that you can keep a consistent span information between like front-end systems and back-end. We call it's distributed tracing or trace propagation. We pass headers along to be able to keep those the spans aligned. So you can do things on the front end. You can do multiple spans inside of one overall call. Just you want to you can get as granular as you want. I tend to like getting more granular because you can see the overall path of something and you get a lot of fidelity out of that. And then the metrics that you want to attach to it. It kind of varies though based on what you're actually tracking. On the front end, you're going to be grabbing a lot different information versus spans that you're capturing on the back end. Back end, it likely end up being a lot of how long did this thing take to complete? What did the API call look like? What was the structure? One thing I didn't hit on that I wish I had is like, we do a lot of things around automatically instrumenting database calls as part of spans also. So you can go in and you can actually see individual query performance for things like Drizzle or Prisma to be able to see like how long those queries are taking, which obviously that's a whole separate span. So you can get pretty granular. It's really depends on what you want to do. What I tell people is, as you have these like important actions inside of your application, you know, like user login, that's an important one. Fetching like a user information, that's probably another one. Saving more information, that's probably another one, right? Like these are all interactions that matter inside of your app. And so like implementing spans around all of those makes a lot of sense. We're actually, there's a big project we're working on right now to redo the documentation around all of like this like custom span sending because people are wanting to do that more and more. Any other questions? The host has a question.
Yeah. You guys have to integrate with a lot of different frameworks and libraries, right? I'm a big Remix fan, and there's a Remix Sentry SDK.
Yes.
And now I'm switching to React Router, and there's a Sentry React Router SDK. How do you guys keep up with all the complexity and integrate with all the new things that are coming out?
It sounds like such a self-serving answer. We should have an incredible engineering team. We have a great team that really like looks at these problems and says, how many people do we need to solve it? Like they stay staffed up, they stay focused on it. There's a ton of SDK work happening all the time across a bunch of those. What I also love like culturally about Sentry is it's very much a see a problem, jump in on it kind of place. I jumped in with Tanner working on TanStack Start over the weekend and helped instrument stuff. Like it's very much a see a problem, jump in and help solve it kind of place. But we should have a really cracked engineering team who does really good work on SDKs.
A lot of open source stuff too. It's pretty cool to go look and see how it works.
Yeah, I'm relatively new to Sentry. I joined about 3 months ago. What's blown me away is how much external contribution we have from like the open source community, all the way down to docs. Like the amount of docs contributions we get from the community, the amount of people who are jumping in and adding stuff. It's a real thing.
Love it.
Totally turned into a plug Sentry, the company.
It feels like it. Like we weren't paid. Well, we got steak, but like we all got steak. No, it's such a nice. Yeah, I like Sentry. Any last questions?
Also, like I said, I'm at Cody. I'm at Cody D. Arkland on Twitter. You can reach me at Cody@Sentry.io. If you have any problems, any issues, feedback, email me. I like to talk. I like to hang out. So if you want to chat, I'll be in the back for a little while before I make the long drive back to Sacramento.
Oh, wow.
I bathe in your pity. I bathe in pity. Come on. Thanks, y'all.
Thank you. Now this will really sound like a plug. There's like free Sentry credit QR codes back there, right? Okay. Sentry is free, unlimited, as much as you want, is what I understand now. You just have to @ Cody on Twitter. Okay, cool. So we're just gonna hang out. Sentry is like, so honestly, Sentry is like way too nice. I was like, what time do we like really need to kick everybody out? And they're like, So we can just like hang. There's a bunch of interesting people here. We'll probably try to head out about 8-ish. But thank you all for coming and see you next time.